Okay, lecture 30 is about something we call S hydrographs. And we use those to change the effective duration of an existing unit hydrograph. It's a way to take a hydrograph, a unit hydrograph you have. Lecture 29, we covered derived unit hydrographs. And so from real data, you can get a unit hydrograph. And then if that unit hydrograph is not the effective duration you need to match your rainfall data, you're going to have to do something to alter that unit hydrograph to make it make it a unit hydrograph that has an effective duration of what you need, because you cannot use a unit hydrograph of one effective duration to match or to match up with rainfall of another time increment. So what am I saying there? If I've got an effective duration on a unit hydrograph of 45 minutes, but I have 5-minute rainfall data, I can't use that unit hydrograph with 5-minute rainfall data. I have to have a unit hydrograph that has an effective duration that's the same time effective duration as the time stamp or the time increment of my rainfall. So we're going to talk about that. And once again, I just remind you that a unit hydrograph is a direct runoff hydrograph resulting from 1 unit of rainfall, either 1 inch or 1 centimeter typically, and it has a certain effective duration. Now, it's, as I mentioned, it's very often that we have to change that duration, and the S hydrograph method is one way to do that. And what we have is we take advantage, the S hydrograph is nothing more than the unit hydrograph you have, and you just keep lagging it by the amount of the effective duration. So if this is a unit hydrograph, let's say of 30 minutes, effective duration, T sub D equal 30 minutes. So every 30 minutes on this, I put in a new unit hydrograph of the same value. And then by superposition, I add those up. At some point, you get to a value of constancy, because now, you've just got this rain. I mean, you think of it as this way. If I have a 1 unit of rain that starts right here when this one started, and then I have another unit of rain, let's call them inches, 1 inch of rain, 1 inch of rain, another inch of rain, another inch of rain, another inch of rain. Each inch of rain causes this unit hydrograph to occur. Well, this is constant all the way through here. We're going out to here to infinity, and I get this S hydrograph once I add these up. This is by superposition. I get this S hydrograph. It's basically from continually lagging a unit hydrograph by its duration and adding the ordinance. That's essentially what an S hydrograph is. Now, there's a detailed explanation. I've got slides from a more detailed lecture I've given in the past that talks about this linear system concept. You can also look this up in chapter 7 of the Applied Hydrology textbook. I've got that loaded, and you can see that, but it goes into more detail on this linear systems business. And I'm not going to go into it in detail about, going from pulses to impulses and all the input and response stuff. But suffice it to say, we've got this issue of proportionality and superposition that are the main 2 concepts of this linear system things that make the unit hydrograph method work. Now, if we look at this, again, this is kind of blowing it up a little bit, but I've got this unit hydrograph here, and then I lag it by its effective duration, start it there, and I end up getting this S hydrograph there. We've kind of talked about that all. So we're going to use the principle of superposition and proportionality to now take advantage of the S hydrograph, and we're going to build an S hydrograph. So let's say we've got a unit hydrograph here of 30 minutes, and I want to take it to something maybe to 60 minutes. So I'm going to take this unit hydrograph, or this S hydrograph, and this is basically resulting from, 1 inch of rain occurring over every, this is 1 inch. So the intensity of this is equal to 1 inch over T sub D. That's the time of the effective duration of that, right? So that's what their intensity is. And so this is rain falling at a rate of 1 inch per T sub D, or, this would be 2 inches per hour if this is a 30-minute unit hydrograph. Now, what I'm going to end up doing is if I want to go to 60 minutes, I'm going to lag and I'm going to put in another S hydrograph. So here I've got the same S hydrograph, but I'm going to lag it by 60 minutes. And so that's what I've got for an S hydrograph. And this is, let me change colors here. This is 60 minutes. 60 minutes. So that means that the volume between these two S hydrographs is equal to the volume right here. Well, what is that volume? That volume is equal to 1 over T sub D times T sub D prime, where T sub D prime is that lag value. This is the T sub D prime is equal to 60 minutes in this case. Do you see that? That basically, because these are lagged, if I have the difference between the two, between one S hydrograph, which is caused by this one, and the next hydrograph, S hydrograph, which is the same S hydrograph, it's just lagged. And the difference between these two is going to be this block in here. And that has got a volume of 1 over T sub D times T sub D prime. And so I'm going to use that. I'm going to take and subtract one from the other by superposition, use the superposition concept. And I end up getting a hydrograph out of that. That's not equal to 1 inch. It's just whatever this volume is between here. Well, that volume is going to be this 1 over T sub D times T sub D prime. And I'm just going to multiply by the inverse of that in order to make this a unit hydrograph. And again, I'm going to go over this in a second. I got another slide to show you that maybe does it a little bit better. And we have a lot of verbiage here that just says exactly what I said. But let me explain this one more time. So we build a S hydrograph. Let me change colors. So I build an S hydrograph. And again, that's from lagging a whole bunch of unit hydrographs of the same effective duration. And that effective duration, in this case, we're going to call it, instead of T sub D, we're going to call it delta T. Okay, just to stay clear with this slide. So every delta T, I've got a new unit hydrograph introduced here, and I build this S hydrograph from that. Okay, now I then, let's erase this. I then take that same unit hydrograph, and again, here in green, you can see that I've got this S hydrograph, which is the same exact one. It's only lagged by the value of the new effective duration. I'm after delta T prime is going to be my new effective duration of this unit hydrograph. That's what I'm after. And so I'm going to lag it a distance delta T down here. And then I'm going to take by superposition and I'm going to subtract one from the other on all these different ordinates. Oop. And so I end up getting a, some sort of hydrograph out of that. That's got some volume that's different than 1 inch. We know that because that volume is going to be equal to whatever this value in here was, delta T prime times 1 over delta T. Where, remember, right, the rate of rainfall is equal to 1 over delta T. And then so this volume right in here, if I've got a rate of 1 over delta T, and then I multiply it by the time of delta T prime, that gives me the volume. Volume equals to 1 over delta T times delta T prime. And then what I'm going to do is, because I know that I've got this hydrograph, that's, this hydrograph, I drilled this in green here, but that's just basically subtracting these ordinates from one from the other to get this value of this hydrograph. Now I'm going to take and divide each one of these ordinates on this new hydrograph in green here. I'm going to divide it by the volume. Okay, and so what is the volume is equal to delta T prime over delta T, or I can multiply it by the inverse. And that's what I do here. So if this is what I'm showing you in this equation. If I've got one SI graph minus the other SI graph, that's what this in brackets represents. And then I multiply it by the volume, or the inverse of the volume, which now is delta T over delta T prime. And so, again, this is just another slide that shows it. You've got the difference here in green between the two SI graphs. That's equal to this volume. I divide, so if I, by superposition, I subtract one from the other, I get this hydrograph. It has a volume of T prime R divided by TR. Again, before we used delta T prime over delta T, that was the volume, right? Remember, that's the same thing. I'm just, using a little bit, this graphic came out of another textbook. And so then I divide each ordinate here by the volume, and that gives me a unit hydrograph, okay? And it's represented here by this equation. Now, when you look at this, there's a little bit of a hint here in this S hydrograph theory. What happens is sometimes you get a problem with oscillation. As you're looking for a value of the S hydrograph to become asymptotic to some value, you often get some oscillation because just the numerical instability of the way you put the numbers together. You can estimate what that asymptotic value should be, this Q sub E. So this would be my Q sub E value here, as this value of Ku, which is a conversion factor, depending on whether it's in British gravitational units or cubic feet per second, cubic foot per hour, per mile squared, inches, whatever. And you've got this one in SI system. And so then you've got area, which is the basin area, and that's going to be in square miles if it's in British gravitational units. You've got a depth of rainfall as in terms of D. And then you've got the effective duration of the unit hydrograph that you're using to make up, this S hydrograph. You're lagging these by some effective duration. If you'll calculate that value, that will help you come up with this equilibrium flow. All right, so we're going to cover an example in the classroom, but you can kind of prime yourself by looking through the slides, and you can see that I've got an existing unit hydrograph that's a 2-hour effective duration. So that would be TD equals 2 hours. I might have, if you looked on the one slide, that's delta T, 2 hours. Just whatever the way you want to represent the effective duration. I don't care. Pick your symbol there. But this is a 2-hour effective duration. What I want to do is I want to move this to a 4-hour unit hydrograph. So this example will show you how to do that, and we'll walk through it in class. But you should take some time to look through the slides to see if you can figure this out yourself prior to coming to class.